Welcome back to my channel, guys. Today we'll be focusing on Aditya-L1, the Journey of Dreams Part 1. Let's visit the launch site once. Launch is taking place from Satish Dhawan Space Center in Sriharikota. The launch vehicle is the most reliable GSK Mk-3, also known as the Bahubali rocket. This powerful rocket will carry the Aditya-L1 spacecraft into the space, where it will empower Konic's historic mission. Crowds chant Bharat Mata Ki Jai as India's maiden solar mission is waiting to lift off. Aditya L1 contains 7 different payloads which is developed at different locations and assembled at ISRO. It includes VELC, Visible Emission Line Chronograph, SUIT, Solar Ultraviolet Imaging Telescope, SOLEX, Solar Low Energy X-ray Spectrometer, Helios, High Energy L1 Orbiting X-ray Spectrometer, Aspects, Aditya Solar Wind Particle Experiment, PAPA, Plasma Analyzer Package for Aditya, and different magnetometers. You can watch the purpose of these payloads as the video progresses. Aditya-L1 shall be the first space-based Indian mission to study the Sun. The spacecraft shall be placed in a helio orbit around the Lagrange point of the Sun's Earth system, which is about 1.5 million kilometers from the Earth. We have created a detailed video on L1 points. Those who want can check out in our playlist, or I will put somewhere in these cards. Before resuming its journey to Sun, Aditya L1 will perform various maneuvers scheduled on September 2nd, September 3rd, September 5th, September 10th, and September 15th. So we are currently in the final stages of the countdown and everything is looking good for today's launch. The scientists and engineers at ISRO has worked tirelessly to ensure the success of this mission. Let's switch over to the live feed from the launch pad and witness the Aditya L1 mission's liftoff. And there it goes, the majestic liftoff. The GSK Mk3 has successfully lifted off, carrying the Aditya L1 spacecraft on its way to the Sun. This marks the beginning of an exciting journey of scientific discovery. Over the coming months and years, Aditya L1 will provide us the invaluable data about our Sun, helping us to unlock the mysteries of its behavior. Aditya L1 is the first space-based observatory-class Indian solar mission to study the Sun from a substantial distance of 1.5 million kilometers. It will take approximately 125 days to reach the L1 point. Aditya L1 will also be ISRO's second astronomy observatory class mission after Astrostat 2015. Now we are going to witness the separation of satellites from the spacecraft. Let's hear the words of ISRO chairman once.
Spacecraft has been injected. Congratulations. The Aditya-L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended.
Congratulations Team Aditya L1 for this remarkable achievement. Let's move on to the next session. Aditya L1's primary objective is to observe the solar corona, the outermost layer of the Sun's atmosphere. It aims to understand the physical process that heat the corona to extremely high temperatures and explore the dynamics of this region. The satellite is designed to study the interaction between the Sun and the solar wind, which consists of charged particles ejected from the Sun. Understanding this interaction is crucial for space weather predictions and its impact on Earth's magnetosphere. The satellite will also study coronal mass injections, which are massive bursts of solar, wind, and magnetic fields from the solar corona. These events can have a significant impact on Earth's space environment. Aditya-L1 will measure the strength and variation of the magnetic fields on the Sun's surface. Solar magnetic fields play a significant role in the Sun's activity, including the formation of sunspots and solar flares. This mission aims to monitor solar flares and their impact on the space weather. Solar flares can disrupt communication system, navigation systems, and power grids on Earth. So studying them is essential for space weather forecasting. Aditya L1 will measure the total solar irradiance, which is the amount of solar energy radiated by the sun. Understanding variations in solar irradiance is vital for climate studies and accessing the sun's impact on Earth's climate. The data gathered by Aditya L1 will contribute to improving space weather prediction models. This information is essential for safeguarding both space and ground based infrastructure and ensuring the safety of astronauts in space. Aditya L1 will continuously monitor the sun's surface features such as sunspots, prominences, and granulation. This information helps us in better understanding the sun's behavior and its impact on space weather. The Aditya L1 mission is expected to foster international collaboration in solar research and space weather prediction by sharing its data and findings with the global scientific society. Visible Emission Line Coronagraph, also known as VELC, is a key instrument on Aditya L1. It is designed to capture images of the solar corona in visible and ultraviolet wavelengths. This instrument helps in studying the dynamics and temperature variations of the corona. This instrument is developed by Indian Institute of Astrophysics IIA Bengaluru. Solar Ultraviolet Imaging Telescope SUIT. SUIT is an ultraviolet UV imaging telescope that observes the sun in the UV spectrum. It provides valuable data on the dynamics and variations on the solar chromosphere and transition region. This device is developed by Inter-University Center for Astronomy and Astrophysics, Pune. Aditya Solar Wind Particle Experiment (ASPEX). ASPEX is another instrument dedicated to studying the solar wind. It measures the properties of solar wind icons, electrons, and their energy distributions. This device is developed by Physics Research Laboratory, Ahmedabad. Plasma Analyzer Package for Aditya, also known as PAPA. This device aims at studying the composition of solar wind and its energy distributions. This device is developed by Space Physics Laboratory, VSSC, Trivandrum. Solar Low Energy X-ray Spectrometer, also known as SOLEX. SOLEX is designed to measure the X-ray emissions from the sun, helping to study high energy processes on the solar surface and in corona. This device is developed at UR Rao Satellite Center, Bengaluru. High Energy L1 Orbiting X-ray Spectrometer, also known as HELIOS. HELIOS is another X-ray spectrometer that observes high energy X-rays and gamma rays emitted by the sun. It provides data on solar flares and high energy solar events. This device is also developed by UR Rao Satellite Center, Bengaluru. Advanced Triaxial High Resolution Digital Magnetometers. The primary object of this device is to measure the magnitude and direction of the interplanetary magnetic field and to study the transient solar events such as coronal mass injections. This device is developed by Laboratory for Electro-Optic Systems LEOS, Bengaluru.